Morning students, welcome again to the practical class of physics. This is your fourth experiment. The experiment title is determine the resistance of a galvanometer by half deflection method. Again I am repeating it. To determine the resistance of a galvanometer by half deflection method. Now this is your circuit diagram, the working diagram for the experiment. You can see here, this is your cell, battery eliminator. From battery eliminator we will give 2 volt EMF to the entire circuit. Then this is your resistance box. This is your galvanometer. This is your shunt resistance. This is E1 and this is E2. Now this is the working formula for the experiment. The resistance of the galvanometer equal to R multiplied with S divided by R minus S. What is the principle in this experiment? The deflection in the coil, deflection in the galvanometer coil is directly proportional to the current flowing through it. The resistance of the galvanometer is almost equal to the resistance of the sun. Because if a current is flowing through the circuit through R, then for the deflection to be half in the shunt circuit, the deflection that we get in the galvanometer circuit, then the current should distribute equally in the two circuits, one through the galvanometer circuit and other through the shunt circuit. So if I current flows through the circuit, then it get divided into I by 2 and I by 2. As AS is negligible over addition subtraction, this part of this equation, as AS is very negligible as compared to R is much more bigger than AS. So this AS factor is negligible. So this equation becomes G approximately equal to S. So in this experiment, the resistances of the galvanometer is almost equal to the resistance of the shunt. The shunt resistance is almost equal to the galvanometer resistance. For this experiment, we have two tabulations. First is table for resistance of the galvanometer, and second one is table for figure of merit. Now, this is diagram for the figure of merit. In this, there is no shunt. The shunt is eliminated from the circuit. In case when we were finding the galvanometer resistance, the shunt was in the circuit, but in this figure of merit, there is no shunt in the circuit, as you can see. Now, what are the various columns for this tabulation? First is your serial number as usual. Second one is resistance in R in ohms. There are two types of resistance. One is a high resistance and one is low resistance. R is your high resistance and S is your low resistance. Since R is much more bigger than S, this S is negligible. Now, serial number, second is resistance in O, the deflection that you get in the galvanometer coil for a particular resistance in the circuit. Then we will find out the half of the deflection in the shunt circuit for a particular shunt resistance. Suppose we got at 5000 resistance in the circuit, the deflection in the galvanometer is 30 divisions. Now we have to find out at what shunt resistance the deflection will be half of the initial deflection. So we have to take care. We will find out the deflection at which it will be half. We will find the resistance in the shunt circuit where the deflection will be half of the initial resistance. Likewise, we will increase 1000 ohm resistances respectively and will find the deflection in the galvanometer coil. Again, by bringing the shunt resistance in the circuit and by closing the shunt resistance key, we will find at what particular shunt resistance there is a half deflection in the galvanometer. After getting this data, we will use this equation and we can see the resistance, the shunt resistance or the galvanometer resistance is almost equal to the shunt resistance, as you can see here. If you compare the data of the galvanometer column to the shunt column, then the data shows us that it is almost equal. So here just I gave you a bird's eye view of the entire experiment. Now here we will concentrate on some points in order to carry the experiment very properly. First of all, the deflection in the coil, in the galvanometer coil, is directly proportional to the current flowing through it. First part. Second, the resistance of the galvanometer is almost equal to the resistance of the shunt. This part we will find theoretically once we do all the mathematics properly. And finally, if I current enters the resistance R in the circuit, then it is distributed equally to the G and S circuits respectively. And in the entire experiment, the EMF is 2 volt. Now I will show you the experimental setup, how the different parts are connected and how we take the reading. As you can see here, this is the experimental setup, the experimental arrangement for this, for finding the resistance of the galvanometer. This is your galvanometer. This is known as keystone galvanometer or moving coil galvanometer. You can see this is known as keystone galvanometer or moving coil galvanometer. So this is a different type of galvanometer that you will be coming across, as like your is not like your conventional galvanometer that you are using while doing the experiment of on meter bridge and potentiometer. Now you can see here there are two resistance boxes. One is here for high resistance and other for sound resistance, where from which will be low resistance to circuit. This is your battery eliminator. This is one-way key and this is the other one-way key. Now we will connect the various parts of the experiment as per the following circuit diagram that you saw just now in the board. And this is your battery eliminator. This is your resistance box. This is also your resistance box. Now first of all, connect the positive terminal of the battery to one end of the resistance box. Connect the positive terminal of the battery to one end of a resistance box. Now take the other end of the resistance box, same resistance box, to the positive of the galvanometer. As you can see here in the galvanometer, it is clearly mentioned which is your positive terminal and which is your negative terminal. Or suppose the positive and negative terminals are eliminated, or so means it is not visible or not feasible, then the red button serves as your positive terminal and the black button serves as your negative terminal. Then coming back, then take one more wire from the positive of the galvanometer to one end of a one-way key. Now take the other end of the one-way key to one end of the second resistance box, or as you can term it as the shunt part. Now from that shunt resistance box, take the other end of the wire, take the other end of the wire to the negative port of the negative terminal of the galvanometer. Then from that negative terminal of the galvanometer, take the wire to one end of the second one-way key and connect the other terminal of the one-way key to the negative of the battery eliminator. Now I will just like to detail brief once more the connection to be very clear. Take the positive of the battery eliminator to one end of a resistance box, not left side, the resistance box. Then take the other end of the resistance box to the positive terminal of the galvanometer. Then from the same positive terminal, take one wire to the one end of a one-way key, and the second end of the one-way key take to the one end of the second resistance box, which will be served us as our sun part. Now from the second end of the sun resistance box, connect to the negative terminal of the galvanometer. Then from that negative terminal of the galvanometer, take a wire and connect to the other key one end, other one-way key one end, and again from the other end connect to the negative of the battery unit. I hope the connection is clear for you all. Now we will see how to take the deflection of the galvanometer from the resistance box, part and from the sun part. Now before this, I will like to disconnect this sun to show you what are the deflections of the galvanometer having only R in the circuit. This act as R for the circuit, and this will act as S, R for the high resistance and S for some resistance and low resistance. Now what you have to do is take the deflection reading, of the galvanometer for higher values of resistances. For example, you take the deflection of the galvanometer for 10,000 ohm, 5,000 ohm, 6,000 ohm, 7,000 ohm, 8,000 ohm, 9,000 ohm, like you start from 5,000 and end up at 10,000. You note down all the individual deflections of the galvanometer for the having R in the circuit only. Now if you stress on the board there, you can see resistance in ohm. It has an 5,000, 6,000, 7,000, 8,000, 9,000, 10,000, and respective deflection in R, deflection of the galvanometer having R in circuit is mentioned in the column. And you can see now we will try to bring one deflection for a particular resistance circuit. For example, take 10,000 ohm in the circuit. We will try to bring the deflection of 6 in the galvanometer. Finally, coming to the last evolution, table for figure of merit. Here we will take the resistance R and deflection theta, and we will use the formula K equal to E by R cross G whole into theta. You can see here figure of merit is given by the formula K equal to current by theta. So current, you can put the formula like E EMF by R plus G whole into theta. Now R and G we can get from the table for resistance of the galvanometer. This is the R column and this is the G column. So now you can see here I have taken 5 readings from the resistance column: 8,000, 9,000, 6,000, 10,000, 5,000, and respectively deflection I have taken from the deflection column of the respective resistance reading. For 8,000 it is 22, 8,000 is 22, 8,000 is 20, slide. We will do some rectification. 8,000 is 20, 8,000 is 20, and deflection of 8,000 is 20, 9,000 is 16, 6,000 24, 10,000 is 6, 5,000 30. So here, if you put the respective values of the factor in the equation, E will be constant for the entire calculation, that is 2 volt. R will be taken from the respective resistance column. G will be also taken from the respective G column of the table for resistance of the galvanometer. G value is written clearly mentioned here. And if you put everything in this formula, the value will come around. For example, for resistance of 8,000 ohm, for deflection 20, and respective G value of 101.26, K, but this figure of merit is coming around 123 point microampere per division. Microampere per division. Similarly, for the resistance of 9000, deflection of 16 and G of 90.90, the respective K or figure of merit will come around 13.75 microampere division inverse. So like this you can calculate for other resistances by using the formula, taking the data from the previous table. So like this you can calculate for the respective resistances. I hope you all have understood how to determine the resistance of a galvanometer by half-deflection method and finally finding out the figure of merit. So I would like to just do a quick recap of the experiment. So in this experiment you have two calculations. One is calculating the resistance of the galvanometer. The formula is G equal to capital R into S divided by R minus S. Since S is the sun resistance, which is very negligible in comparison to the resistance of R, so S is neglected in this equation. So the resistance of the galvanometer will be almost equal to the resistance of the sun, as you can see from these two columns. Here the sun resistance is 100, here G is 102.04, 70, 70.82, 120, 122.09, almost it is equivalent. And this is the circuit diagram for the galvanometer resistance, and this is the circuit diagram for the figure of merit. And finally, figure of merit calculation formula is K equal to current by theta. Theta is your deflection factor. So we will substitute I as EMF E whole R plus G whole into theta. And the unit will be ampere division inverse. This is current and this is division, so ampere division inverse. So I hope this experiment is clear to you. So now, thank you.